Okay, welcome everybody. Once again, for those of you who caught the show yesterday, thank you for coming back. You're the diehards. I appreciate you coming back. For all of the people who didn't catch it yesterday, I'm going to review just really quickly what I talked about, and then kind of move on to the analytics stuff. But I did want to just recap a little tiny bit so that the new people aren't completely lost. As always, feel free to interrupt me as I go. I don't mind. I can't. I'm not going to pay too much attention to the chat. So if somebody wants to get in there, just let me know. I'll try to look at the chat, but I can't see it when I'm presenting very easily because my screen's kind of little. And so what we're gonna do, I'm gonna capitalize off of sort of what we talked about yesterday, which was the serverless web app. And today I'm going to show how you can sort of build a serverless data analytics pipeline, sort of based on what we did yesterday, in kind of a limited fashion, just given the amount of time. So let's move ahead, and let me talk just really quickly about just I wanted to cover, and I really didn't talk about it yesterday. Amazon's first leadership principle is being customer obsessed. And so I talked about this yesterday a little bit, but everything, 95% of the functionality in AWS is driven by customer demand or customer requests. And that's actually what's sort of even driving the serverless technologies. And so that's what is kind of driving even what we're sort of talking about today. A lot of this functionality was driven by customers asking for this functionality, and asking for the ability to go to market faster, and the ability to have high scalability and high performance, or higher performance and higher scalability. Security by design and isolation by design, and all of this with a lower total cost of ownership. So and those requirements really never change. They're always going to be that way, and they're always going to keep challenging us, Amazon and AWS, to keep improving the AWS services and the AWS platform. So what is serverless enables, based on those drivers that we just saw? Serverless enables a lot of those via these kind of four big principles. Agility, so serverless, as we saw yesterday, but we'll also see today, enables you, the developer, to deliver faster with less of that what we call undifferentiated heavy lifting of managing your own on-premises or managing your own infrastructure. And I'll keep bringing that up because it's kind of an important topic, and it's really one of the biggie drivers for serverless. Performance, because like we saw yesterday, because you can build out these serverless components and wire them together with events, that allows you to scale to handle your customer demand really, really easily. So you really don't have to think quite as hard as you would if you were deploying virtual machines and having to scale all that manually yourself. Security, as we'll see, by the serverless components, that allows you to transfer or to sort of delegate a lot of the security that you worried about before. A lot of that security can be delegated to Amazon to capitalize off of all of Amazon's security knowledge gathered over the many years that they've been doing this. That allows, it doesn't mean that all security is offloaded off of you. You obviously have to worry about security too, but some of that can be offloaded to Amazon to allow you to worry about the security things that are the things that you should and want to worry about. So we talked about this yesterday. I'm going to cover this really fast. Serverless is more than just compute. It's also AWS Fargate, our serverless container service. You probably don't think about it, but Amazon S3 Simple Storage Service, our object store, that is also a serverless offering. We're going to talk about Amazon Aurora today. That's our MySQL Postgres compatible RDS database with open source kind of convenience and simplicity, but with enterprise performance. Amazon DynamoDB, we talked about that yesterday. That's our NoSQL database. And all of this kind of tied together at the bottom with Amazon Event Bridge and API Gateway, which we talked about yesterday, SQS Simple Queuing Service, Amazon SNS Simple Notification Service, which is like mobile push, SMS, email, things like that. AWS Step Functions, which allows you to orchestrate all these components together in kind of a workflow way. And AWS AppSync, which is our managed GraphQL offering. What we talked about yesterday was this simple web app. I'm not going to cover it too much, but obviously CloudFront CDN, static content off of S3. We built the API gateway, Lambda CRUD operations, and DynamoDB. That's what we built. So we built an entire REST API yesterday in front of you very, very quickly. Not going to talk about that, but that's what we built right there. And I'm going to add on to that now and talk about how you would build a serverless analytics system downstream from that. So obviously, if any of you who are familiar with analytics and visualization, you wouldn't want to, you typically don't build your analytics system off of a transactional database like we had with DynamoDB. So DynamoDB is fantastic for serving your data via your REST API. It's not well suited to an analytics aggregation OLAP type of environment. So the way we would solve that is by using a streaming, the event streaming out of DynamoDB. That's called DynamoDB streams. We would run that into a Lambda function in order to convert that into an Aurora, in this case, in an Aurora MySQL database. Now, normally when I've given this demo, I've done this with Redshift, and that's because Redshift is our premier data warehouse platform. But today I'm showing Aurora just because there's a lot of interest in Aurora, and it's just like really cool and fun to use. And I think a lot of people would probably get a lot of benefit out of it. So I'm gonna swap in Aurora for Redshift here, and then Quicksight as the visualization system. So this system right here, to build out that system, is quite a bit more complicated than I was prepared to do. So I'm going to show you in a second what I am going to build. But let's talk a little bit about Amazon Aurora just very quickly. It's delivered as a managed service. It's drop-in compatibility with MySQL and Postgres. It's gives you the simplicity and the cost effectiveness of an open source database, what you're always, what most of you have probably used a lot. It gives you the throughput and the availability of a commercial database. So that's really its big selling point. It also is really, really nice because it uses the simple pay-as-you-go model of AWS. So you pay for what you use and you don't pay for what you're not using. And it gives us all those benefits we talked about before, where you can scale up and handle the demand, and then scale back down to where you're not using and not paying for it. So let's talk Aurora. Just a few specifics about Aurora. It has 5 times the throughput of standard MySQL, and it's got 3 times the throughput of standard Postgres. It can scale out to 15 read replicas. And so it's really, really fast and very durable and performant. And we'll look at that. It's got self-healing storage. It will do 6 copies of data across 3 availability zones, and it does continuous backup to S3. So again, highly durable, highly available, and very, very performant. It has network it does network isolation, and it does encryption at rest and transit, which makes it able to be compliant with a lot of the compliance programs that some of us have to adhere to out there, like in healthcare. That's what we all have to adhere to, like for HIPAA or high trust. It is a managed Amazon RDS service, so it's got a very familiar API to it in the console and through the command line interface and through a programmatic interface. It does not require you to do server provisioning or software patching or any kind of setup or configuration or backup. So that's that benefit of a managed service. I talked about Quicksight, and I'm going to talk really just fast about what it is. If you're familiar with like Power BI or Tableau, which I'm a big Tableau fan too, our new CEO of AWS comes from Tableau. It's our kind of integrated offering. It's pay as you go, which is really, really super nice. You pay only for what you use in Quicksight. It has it's a per session fee for the people who are just viewing the report. So you only pay, I think you pay 30 cents a session up to a maximum of $5 per month for the people who are looking at the reports. So really, really cost effective. It's fantastic about that. It can deploy globally to hundreds of thousands of users without you having to provision any servers. Again, serverless benefit, very, very high availability. It's secure by default, private access to AWS data, and it's integrated with S3 and the S3 data lake as well. It has a programmatic interface, so you can do everything you can do in the console where you're working on user management or building visualizations. All that can be done programmatically, and it is allowed to be embedded into your application. So that's super for in the cases where you're trying to embed the specific visualizations, you're building them perhaps in Quicksight, and then you're embedding them over in your applications. So really full featured in that way. Lastly, machine learning. It's got built-in anomaly detection and forecasting. You can actually load your own Amazon SageMaker models into it to use those functionalities in your visualizations. And it has a natural language ability where you can give it natural language queries, and so it'll build visualizations off of just kind of typing in what you want. So as far as where Quicksight kind of typically lives, I'm going to show you an example, but in this particular case, I'm showing an example of just kind of like a serverless data lake view where maybe you're dropping large quantities of your data into Amazon S3, forming your sort of data lake storage, using AWS Glue to kind of crawl that data, compile it into catalog, and sort of allow it to be then used downstream through these other serverless offerings like Amazon Athena, Amazon EMR, and Amazon Redshift Spectrum. Athena and Spectrum I'm going to call out because those are particularly cool technologies. Athena is an interactive query service that makes it easy to analyze data in S3 using standard SQL. So you can just leave your data in I think it can be in JSON or in Parquet and things like that. And you can just run SQL queries right over the top of that. So that's super cool and very convenient. In that case, you don't even have to do ETL. And then Redshift Spectrum is the same concept, but now using the Redshift engine and the Redshift query processing and things like that on top of S3 data as well. So you're getting the power of those heavy high performance query engines, and you're running those queries over data in S3. So very, very cool. Okay, so we talked, I showed this in a second. This is kind of like what the kind of prototype is. However, I'm gonna, because that would take me far longer than I have, and I'm gonna try not to go quite as fast as I did yesterday, and not just do a bunch of consoles flashing screens for you. So I'm just gonna, I've got this solution kind of already built, and so I'm just gonna walk you through the pieces of it that I think you're interested in. I'm gonna show you how to do some of it. So if you're playing along at home with the home game, here's what you would actually do. You would create an Aurora MySQL cluster. You would create your tables, run your DDL scripts to get the data schemas created. You would configure Quicksight and Aurora connectivity. You would build a Lambda function to do that connectivity between S3 and MySQL. Now, in the original picture I showed, that Lambda function would actually be processing your DynamoDB streams instead, so real-time change data capture like stuff. But here, I'm just simulating that by pulling the data off of S3 instead. and then you'd build your visualizations, and voila, you've got your serverless data analytics pipeline. Okay, so before we take all the advantages of serverless, I'm going to switch now to, let's switch over to showing you in the console, and let us go. Okay, so here I'm in the console here. I just want to make sure everybody can see that. Can everybody see the console now? Can somebody, I don't, if somebody can give me a,
Yes.
I just want to make sure everybody can see it. Okay, good.
Yeah, we can see it.
Okay, and I'm going to make it a little bigger so that everybody can get a good look here, because I know I was kind of small there yesterday. So I'm going to start out. First thing I'm just going to do is start out and show you what this would sort of look like in the in S3. So like I said before, I've done this demo before in using Redshift. So ignore the fact that my bucket name is called Redshift, but this applies just as equally to Redshift. So if you wanted to, all this knowledge translates very well into Redshift. So I've got my bucket here, and I just wanted to show you what that looked like. I've dropped in these files, and those files I'm going to actually paste that right now for you into the chat. And I always struggle bringing all this up. Okay, so in the chat right now, I'm going to paste where I. This is actually the Redshift. This is the Redshift demo or tutorial that I pulled this data from. If you follow this Redshift tutorial, you can actually do the same kind of thing that I'm doing here in part, but I'm gonna now switch it out to be Aurora MySQL. So I've expanded all these out. Now, what I did is I've already created those schemas. These schemas, each of these relates to a table. I've already created those over in Aurora. And just for the sake of time, I've already imported the data even in, but I'm going to show you how to sort of go about doing that. So I just want to show you what the data files look like in here, and I'm going to click on one of these just to show what it looks like. It's just a pipe delimited. It's kind of small, obviously. Pipe delimited file. Here, I'll kind of make it sort of bigger here so you can see. So pretty standard stuff. And what I'm going to show you really fast, because I think this is cool and it's something that you could do for lots of other things. I'm going to show you how to create a Lambda function really fast that will respond to files being dropped or changed in S3. So this is kind of part of what you would do to implement that solution I showed you. So in this particular case, we didn't do this yesterday, but I'm going to use a blueprint, a Lambda blueprint, and these are components of code bundled with all the permissions and everything needed to just out of the box get you up and running really fast with a specific use case. In this use case, we are going to search for S3. You can see right here, in most of these cases, you'll see that the blueprint, if it's a JavaScript-based blueprint, you'll see that it just has the name. And then if it's a Python-based blueprint, which is the Python equivalent, it'll have Python appended. So this one right here is a JavaScript blueprint. I'm going to choose this, and we are going to configure this. And like we did yesterday, one of the coolest things about doing this again is the security plane and the way that AWS handles this and allows you to extract that security using policies and roles out of the actual functionality. So that's what we're going to do here. We're going to configure the role-based permissions to connect our Lambda function over to S3. And I'm going to call this, let's see, what can we call it? Well, I'll call this MySQL to, no, sorry, S3, I'm doing it backwards, to MySQL Lambda role. Oh, and I'm going to, I skipped actually naming my function. We're going to call this S3 to MySQL Lambda. And I'm going to choose, oh, it's already kind of chosen this for me, but here, let me get rid of this just in case. I'm going to choose, I'm going to use the search here to choose my policy template here, and I want it to be Amazon S3 object read-only permissions. You'll see it adds it right there, so that's good. We can get rid of that. So now you can add as many policies as you want. Those are enabling more and more connectivity into things. With the idea of granting things the least privilege you can, we're just going to grant it just the permission to access S3. Now, again, in this setup, it's already going to let me choose to trigger this Lambda function off of an S3 bucket. This is fantastic because it's just letting me, it's just doing this all for me in the configure screen. So I don't have to do anything else after I get this. It's basically going to run after we get this set up. I'm going to choose my bucket, that Redshift demo bucket. I'm going to stick with it being notified and calling the Lambda on all object create events. I don't need to specify any kind of prefixing into the bucket, meaning specifying paths in there. And basically, that is all it is. I'm just going to review and make sure we got everything in place. And that's about it. This is the code it's going to put in, and I'm going to modify this code briefly just to show you what it looks like. And it's going to take a second here. And oh, I've got a I've got an error because I already had an overlapping event, so I think I messed up the trigger on that bucket. So yeah, I messed up the bucket. But anyway, because I did this, this is kind of funny. So I did this right before earlier today, and so it's complaining up here that I've already got a bucket notification here on my thing, so it doesn't want to do two of them. So that's actually what's happening. So in the and I don't want to waste too much time fixing this in front of you, so we're just gonna imagine that that's actually the correct setup, because it actually is. And I could probably go in here and fix that by going into properties, and I could probably delete off that event notification right here. This is it right there. And if I delete that off, it will actually it'll actually correct the problem. But I'm not going to bother that, because I don't want to waste your time with me debugging and fixing this. I think you get the idea. That's actually how you would set it up, and that's how you would now be notified when a file is dropped into an S3 bucket, a new file. That file will go in there. It'll hit that trigger and now generate that Lambda function to be called. And so what we would have to do at this point is, and I'll go back to my Lambda function here. Right there, that guy. What we would do now at this point, this template code doesn't have the code to parse the pipe separated data out of the S3 and actually put it in. So I'm sort of leaving it as an exercise for the reader to or for the viewer to go in here and actually add that code. But that's fairly straightforward to do. You're just going to parse the data as it streams into the Lambda function, and then you're going to connect to MySQL and execute the SQL calls for that. But I'm going to now skip over, and just in the sake of time, I'm going to show you, we're going to skip over, I chose the wrong thing. I chose API Gateway. So this is what we did yesterday. I'm going to choose RDS, hit return here. We're going to go over to the RDS database browser, and I'll show you. I've already got the, I have the database already running. And we're a little bit slow here. Maybe my internet connection is a little slow. There we go. And let's go look. I've got a Aurora cluster already defined, and it's actually already got the data ingested into it. Again, didn't want you to have to sit there and watch that. So just a couple quick things to notice. In this particular case, there's a reader instance and a writer instance, and if we click on those, it'll actually show you both of those right here. And this is typically what you would use for reading data for analytics. You would typically use one of these, one of the reader instances. So writer instances are obviously what are being fed the data. So if we were feeding data into this from a DynamoDB stream, like we talked about, the writer instance would be, you'd want to keep that writer instance as unencumbered as you can, so that those streaming events are coming in at full speed. So we're going to build our Quicksight visualizations off of this reader instance. that's a replicated, synced reader that we can use, and it won't affect the performance of the writer. And that's about all I was going to show you. When we get done, I'll kind of leave it up for questions. If you want to ask questions, we'll have more, but I don't want to bog you down too much here with too much. So what we're going to do now is we're going to switch over to Quicksight. I'm going to show you that. And I'm actually going to build a little visualization here just so you can see what that looks like, just because it's kind of fun to do. I'm going to, okay, so this is Quicksight. Again, integrated in with AWS. Really, really super kind of intuitive to use, especially if you come from Tableau or Power BI. You're going to love this thing. I'm gonna do a new visualization and a new data set, and so you're going to see me do all this right in front of you. I'm going to use Aurora. I'm going to call this data set, let's call it the ticket prices ticket sales. How about we'll call it that? This thing is it's this data set, like I said, I got from the Redshift tutorial. It's basically a bunch of ticket sales for a bunch of events that happened, and this data set only has for 2008 data, so it's a smaller data set. The database server, I'm just going to paste in here. That is our reader. The MySQL port 3306. Database name, I very unimaginatively called it demo. It's not very smart. I'm gonna do a sort of a not suggested thing. I'm going to use the admin privileges that we set up on that database. You obviously would not want to do that, but for the convenience of this, it's going to be fine. And I'm going to create that data source. So you can see now what it's actually doing here is it's going to ask me, what do I want to base my visualization data on? I'm going to choose event, and I'm going to actually build, I'm actually going to build this query up from a couple other tables too. So I'm going to add another table. It's going to be category I'm going to add, and I'm going to go pull this query because I don't have it memorized. I'm going to pull one more query just to show you that I can do it. I'm going to add another custom SQL. Oops, I did that really fast. I'm sorry. I just added another custom SQL data source. I know I flashed past that too fast. And I'm going to paste that query in here. Oops, got some formatting in there. I'm just going to get rid of that. So I'm just going to paste in a custom query again, just to show you that I can. It's from the sales table, and it's just going to be the sum of the price paid for the tickets. I'm going to apply that. We will see, it will give me some sample data. Okay, so now we got our data set. Now I'm going to tell it how to join all these columns together. So I'm going to push on these little things right here, choose inner join, and I'm going to then choose from here, I'm going to tell it how to do the join. In this particular case, I'm going to join events to categories using the category ID on both of them. It's the same column name. Okay, that's all set up. So I'm going to push apply. I'm going to do the same exact thing for our other table here, do an inner join, and I'm going to select here the event ID to event ID. So that's how we're going to join our data. I'm going to push apply, and we're going to look at our final data set here. So it's now giving us the full inner join of all three of these tables, and that's going to be what we're going to base our visualization on. So I'm going to push save and visualize here and go to our visualization. And first thing I'm going to do, and this is what's really fun about this this whole thing, is just the ability. I use this thing not just even to build visualizations for other people, but to just, if I got a bunch of data and I want to figure out what the structure of that data is, I'll just use this as a method to do it. So I'm going to build a pie chart. So I'm going to click down here at the bottom on pie chart. I'm going to do it on ticket sales, and I want to color the pie chart by the category name, and you'll see what that does. So it's just going to give me a regular pie chart. Ticket sales is the size of the pie chart, and I'm going to do one thing here. I'm going to order by category name here. That's just a technicality to keep all the colors straight is what I'm doing. I'm going to create another visualization now really fast. We're already done with that one. And I'm going to change this one. I just copied this one is what I did. So I chose this duplicate visual. It's just a convenient way to get another one over here. I'm going to now click on stack pie chart here. And what I'm going to do along the bottom here, along the x-axis, and I'm going to set these values by dropping them in these wells right up here. So I'm going to choose start time for the x-axis. You see it just uses every single day, and I don't want it to be day. I want it to aggregate here by the month. Let's do that. So you see it's going to aggregate our stack bar chart like that. We're just getting single bars here, so let's categorize this with color by adding it to this group thing. And I'm going to use the category, and the categories, if you look over here on the left, those are the categories of the tickets. So it's pop, musical, opera, and play. So I'm going to drop that category name into the group by, and now we're going to get our colored stacked bar charts by that. So now we've got our pie chart that shows us the breakdown overall of all the sales. I've got your you've got your ticket sales here by date, and I'm going to add one more thing really fast, and that is going to be, I'm going to do it like this: add a visual, and I'm going to add a pivot table down here at the bottom. So the same kind of deal. I'm going to drop these into these wells up here to generate that, and I want the event name to be the rows of our pivot table. So you'll see it's going to come up. I want ticket sales to be the values that we're going to see. And I want the columns across the pivot table. I want those columns to be the date. I guess I'm going to do it by quarter. I want to see these by quarter is what I want to do across the top. And so I'm going to choose the aggregation here again to be quarter. Voila! I've got now. I'm going to order the whole thing now by ticket sales, and I'm going to order it by ticket sales descending. There we go. So now I've got all my visualizations. Last little piece I want to be able to do is slice and dice. Oh, here I'm gonna squish these so that everybody can see on the screen at once. I know that it's kind of hard to see everything at once. So I'm gonna move this back. This thing doesn't have to be nearly as big. So I'm gonna try to make them kind of small so everybody can see. There we go. Now what I'm gonna do is I want to be able to slice and dice through this data, and I want to see the other ones react when I click on a particular thing. I want to be able to use that as a slice and dice. Slice and dicing is like the coolest thing about Quicksight. The other products do it. Other products like Power BI and Tableau do it too, but it's just so easy to do in Quicksight that it's like super fun to do it. So what I'm going to do, I'm going to add an action to each of these that is going to allow us to do the slice and dice. So what I do is I use this quick create, and on each one I have to do it on each one just to tell each visualization that I want to use it. Now I've done that. So I did that kind of fast. I'm just going to show you again. I pushed action, and then I pushed this quick create, and you can see on each one I've got the action created. Now the beautiful part about this is I can click on individual things on a particular visualization, and it'll slice and dice the visualization based on that. So I chose plays. Now we can see ticket sales just for the plays, and we can see in the pivot table, we can see just plays down here. The one thing I didn't do, and I actually don't know how to do this, is make it so that this bar chart has the same color as the plays. It's orange. I couldn't figure out how to do that, but I'm sure there's a way to do it. So we can choose musicals over here, and it filters by that. If I wanted to do, let's say I wanted to filter on musicals right there that I did, and I want to filter just to see Jersey Boys, I can click down here on Jersey Boys, and now we're seeing Jersey Boys sales by month, and of course up here in the pie chart that accounts for all of them, just but by the nature of the filtering. So it gives us abilities here to sort of slice and dice again. I can slice and dice over here too by the month, so I can see if I wanted to see musicals that occurred in October of 28. There they are right there. Again, just the ability to slice and dice through data and just understand what that structure of the data is and how you want to use that data going forward. So it's just it doesn't even have to be for building visualizations for other people. It can just be as a data analysis tool for use. So really, really super useful. And that is going to bring me to the end of my high-speed tour through the serverless analytics, I'm gonna take us back to our presentation here, and let me do that, and just recap the same exact things we talked about yesterday. These are the same takeaways we had. Serverless, these are the beauties. When the serverless platform, when you're not incurring demand or when no one's using it, your costs are very slow, are very low. So low cost when idle, but when you become internet famous and the demand hits, and all of a sudden everybody's hitting your web app, or they're hitting your analytics, or whatever they're hitting, the thing will scale up to meet that demand, to virtually unlimited scalability. And you really don't have to think too much about that scalability. You're not building out all the things that you have to build out when you're building scalability, the way you did traditionally, say, on VMs in EC2. Again, like I said, you're pushing responsibility onto AWS, taking advantage of all of AWS's expertise on security. Doesn't mean that you're not handling security yourself. You're just pushing some of the lower level security onto them. And by nature of doing that, and by nature of pushing to these managed solutions, that means it relieves you of having to deal with that undifferentiated heavy lifting that you have to deal with normally, either on-prem or managing EC2 instances. Last but not least, and I'm going to do my call out to Michael Alvis, who I would say that Michael Alvis, he would kill me in my sleep if I didn't mention that all of this can be done with infrastructure as code. In the AWS case, that's CloudFormation, but you can also do that with Terraform. What I like to do is I like to run through, just like I did, build out the thing in the console, and then capture all that knowledge while it's fresh in my mind, capture all that knowledge into infrastructure as code, just so I can remember how I did it. Because literally, like, if I come back to that a month later, I will not remember how I did all that. So having that captured in code, so that now it's like a language you can actually hand to somebody else and say, here's how I did this. You can just run this and instantiate this in your own environment. So I highly encourage the infrastructure as code through CloudFormation. If any of these topics that I've kind of hit on here, including infrastructure as code through CloudFormation, or any of the other things, Aurora, if there are other deep dive things that you would like to see in the future, definitely let me know, and we can do more deep dives on those technologies specifically. I've kind of covered them at a high level here, just so that you have a summary kind of knowledge of what they are. But I expect that as you develop interest in these, that you'll come back and maybe want to do more deep dives. If anybody out there has experience in these technologies or using these successfully, like we talked yesterday to Alex, who's on the phone today. He was successfully using these technologies in his startup, and it was great to hear that all of the things that we at Amazon have hoped to deliver with the serverless technology, it sounds like that it is really coming to fruition. So with that, I am going to open it up to questions, and anybody with similar experiences, or anybody that has used this. Oh, I see Alex coming up on video. Alex, have you done any of the serverless analytics? Have you done any of that?
No, I have not. Primarily because we're at the beginning stage and we didn't release our first product yet. So we don't collect any data from any users because we don't have any users.
Gotcha.
So unless anybody else have questions related to the call.
Yeah, anybody else? Yeah, Alex, anybody else? Because I bet Alex has more questions, and I bet he has. Is there anybody out there? Is there any piece of this? Let me ask this: is there any piece of this that's especially interesting to you that I could do, or that we AWS that we can do other deep dives on specifically to see more kind of detail on these kind of things? I know it's kind of a lot. I threw a lot at you, but it may be that I can.
Tyrone's got a question.
Oh, Tyrone. Yeah, go for it.
Hey, how you doing?
Hey.
I really appreciate this tutorial.
Oh, sure.
One of the things that I have a question about as far as with the Lambda functions, I think the max is like 15 minutes. Can you
That's right.
can you tell me what would be a situation where using a Lambda function would not work?
Oh, that's a great example right there. So let's say you've got a batch process that you're going to invoke and it takes more than 15 minutes. So like, it's going to take an hour to run or something like that, or it's going to take 10 hours to run or something like that. And you can't break that problem into smaller pieces. Then that's a great example where you would not want to use a Lambda function. So you would want to do something more along the lines of potentially running something in, say, for example, in Fargate, the serverless container system. You can also run it in just the regular container systems. Now, those are provisioned on EC2 instances, so you would be starting up EC2 instances. So we're kind of off the serverless track there, but that's okay. Because the other thing that I was going to say about if you've got long running processes like that, there's a lot of stuff, there's a lot of capabilities that you can do to start up those instances and bring them down and scale them up and things like that based on usage. So for example, you can bring up an EC2 instance or a ECS, EKS, the container systems. You can bring up containers on a schedule, for example, or on a trigger. If you drop a file into S3, you can start them up, run your batch process, and drop them down. But there are other cases where I would say Lambda gets more and more less and less applicable and especially if you're dealing with I would say the batch process is the best example of that. Another example would be if you've got some legacy application that will not run in a Lambda environment. So if I brought this up yesterday, but the Lambda environment is typically you're running Node.js, JavaScript, Python, Java, Go, Ruby. You can run in custom environments, but I'd say if you've got a COBOL app that's running, for example, that's probably a bad example. I know it's kind of a silly example, but those are the ones I can think of. I bet other people who have used Lambda functions, like my friend Michael Alvis, he's made heavy use of Lambda functions. He could probably come up with lots of examples of where not to use Lambda functions. But does that answer your question, Tyrone?
Yes, it does.
Okay.
I really appreciate that.
Have you ever experimented with that, or do you have a specific kind of thought or a use case you were kind of thinking of it for?
Question. I'm not sure if you can hear me. I think my video.
Yeah, is that John?
Yes. Yeah. Hey guys. So I'm glad to be with y'all. I'm a program developer at Amazon actually, and I work at the BHM Fulfillment Center.
Oh, okay.
I get to work with AWS services quite a lot, and
nice.
Especially developing tools for our Amazon robotic sortation network. I have worked with all of these services, and I've worked with Quicksight creating dashboards.
Awesome.
But I have not connected Quicksight to an event. It looked like when you were setting up the configuration of your table and essentially like how the joins were happening, it looked like there was something called event, and then it was hooked up to and like joined up to another table. Like, is that a weird nomenclature to call that event, or could you go into that?
That is a weird nomenclature. That event, that table, and not to be confused with Amazon AWS events. So it had nothing to do with events. What that event table was music events. I mean events like you'd go to a concert, like that kind of an event. So it's just a bad overloading of the term event. But that database is just a database of.
Okay, gotcha. I
You
got
see what I
the
mean?
very tail end of
Yeah.
that
Yeah. Sorry about
answer.
that. Yeah.
It was just saying it's a bad overloading. But
Yeah. Did you say you didn't hear me? Is that what you said?
no, I didn't. But I caught the end of it. So I was just like getting it, I guess, confused with the notion of like an event that triggers
Exactly.
Lambda. And so I
Sorry.
was
Yeah. That is just
oh,
a bad overloading of
Mhm.
that term. Yeah. Those events in there, those were not AWS events. Those are concert events. So, I probably should have, they should have called it something else. I didn't name that myself. It came out of that ticket sales database that I
I do
pulled
have
up.
one more question, if that's okay.
Oh, sure.
If you have
Yeah.
time.
Yeah.
What is the best platform on AWS to do data analytics from a Kinesis Firehose?
Oh, to use Kinesis Firehose? The best platform, maybe you can be more specific. I'm not sure exactly what you're asking.
I'm going to say service. To do visualization for live stream data from a Kinesis Firehose. Like, do we need to take that data stream that's coming in, put it into a table to be able to do analytics on it? And then if the table is constantly changing, then how is the analytical engine able to, aggregate and like, so that's what I was wondering, what's the best service to do analytics from a data stream?
Well, so I like the idea of data of Firehose. That's a great use of that to keep your analytics database up to in sync with whatever upstream data is producing that, and that could be anything like you're saying. But if you're asking about landing that data, say into Aurora, MySQL versus Redshift or something like that, and the idea that the data is changing underneath at a very fast pace, that's actually true. But that's why you want that kind of live sync. That will not mess up if what you're asking is that won't mess up your visualization system on the tail end like Quicksight. The Quicksight will just roll with that. You do have the potential that if you're loading data in that is not transactional and you're not transactionally adding data into the database, you do have the potential that your analytics data might get a little wonky for a short amount of time. What I was going to say though, and I didn't really cover this, I didn't show this at all, but most of the visualization systems, Tableau, Power BI, and Quicksight, in Quicksight's case specifically, I was using, and I didn't talk about this, I was using something that's called Spice, which is a very, very high-speed parallel in-memory aggregation computation engine that's part of Quicksight. And what that does is it provides a little bit of an in-memory cache between your database and the visualizations. So it's like thinking of like a very high-speed in-memory columnar database calculation engine. And so what that actually does is you can ask Spice to refresh from your database on a little bit more of a regular schedule. So you don't have to, in other words, you don't have to run SQL queries every single time you're browsing or you're slicing and dicing in your visualization. You don't have to run those queries down to the database every single time. You can use this in-memory columnar calculation engine to kind of buffer yourself from maybe performance issues if you've got, if your database is slow or whatever. It just makes it makes it Wilson asked if S3 is if Spice is priced separately. Spice is part of Quicksight, so I don't think it's priced separately. I think it's part of the Quicksight pricing. But that's how I would recommend, if that's what you're wondering, how I would recommend kind of staying a little bit disconnected from the database if you're worried about that kind of transactional volume or something like that, if that answers your question.
Yeah, it does. And that's really awesome that the database can be changing as you're as you're analyzing it.
Yeah.
Uh,
Yeah.
yeah.
Because I don't know if you know this, and this is actually one of the cool things about how Quicksight works, but when you're slicing and dicing, when I was sitting there slicing and dicing through the data, clicking on particular things, what it's actually doing is it's actually generating SQL queries and running those SQL queries down to the database live. Now, it's doing that if you don't use that Spice caching capability. But if I weren't using Spice, it would be running those database queries right down to the database engine. But anyway, so we're right at time. We have 1 more minute, so I'm going to hand it back to Jeremy. I'm glad.
I'm going to take over to.
Oh yeah, Justin. But
Yep.
Thank you, everybody. Thank you for coming. It was awesome. Yeah, thank you for the questions, everybody. Super interesting. I think I'm going to go to the base event tonight. So if you all are there, hit me up and we'll talk more. So Justin, take it away.
Yep. Thanks everybody for coming. I will have the recording posted to YouTube in a few days. Got links in the chat. If you've seen, hit us up if you need any information. And just thanks everybody for coming. Hope to see y'all next month.